So today we'll talk about how to optimize for size. Why? Because nobody likes slow application, and I can tell you that probably most of you already had a problem where you were about to release to production and you realized that it is taking forever to load something, that the whole bundle is huge, that your application consumes a lot of data, and there are just problems, and users usually can see these problems very quickly, and especially on initial load where they visit your site for the first time. That's why we are battling this, and I'll offer a high-level overview of what you can do and how your app can be smaller in size. I'm Vojtech. I'm Angular and TypeScript enthusiast. I like to speak, I like to teach, share the knowledge. And I come from Czech Republic, and where my company is based in. And Czech Republic is, as you probably know, they invented the beer as we know it. And that's why we organize meetup, which is called NG Beer. And it's about quality beer and Angular. So it's a really good meetup, I can recommend it. So what can we say about the application do's and don'ts? So if we start with do's, if just from top of your head, what should you do in your application to get rid of something, like to improve? And if you want, you can just shout out random thoughts. Lazy loading, yes, definitely lazy loading. Something else. Tree shaking, thank you. Okay, yeah, compression is also a very good topic. Something else? No? We can go through all of them. Everything named: compression, asset optimization, lazy loading, intelligent build toolings, where you can minify stuff, where you can tree shake, and when you can optimize ahead of time, do the compilation beforehand. And what are the don'ts? What do you usually, when you hear it, you know this will be a problem? Something. No? Nothing? I can tell you. You import non-tree shakeable things. Big libraries, you cannot do anything with them because they are just huge, depending on a lot of internal stuff. You do a bad import. Example of a bad import would be importing from RxJS internal. Sometimes the IDE will offer you to import from wrong path, which is used for internal use only, and it can result in horrible things in the application bundle, because suddenly you can notice that your main bundle can be a megabyte larger just because there are internal things in it. You have a big shared module. It's a big no-go. You are messing with third-party tracking scripts. You put a lot of them, recording, Google Analytics. You have like 10 third-party scripts there. It is bad for your application. You have to do it correctly. And you have non-optimized web fonts. Again, something you should always take care of. It's not only about JavaScript, it's also about the assets and other things in your app. So let's start with the compression. What do we know in today's world as a good compression algorithms? There are basically two. One of them is gzip, and gzip is there for forever. You can see it since IE6. So that's like, I don't know, 15 years ago at least, maybe more. There is absolutely no reason why you shouldn't use gzip. Every application should be deployed on a server that does the compression, or you should do the compression beforehand. What you can do even better than gzip is to use Brotli. Brotli is widely supported, it's lossless, and compared to gzip, it is supported by all current browsers. What I mean by current, you can see it basically everything. Like if you don't use EA, then you can use Brotli. What is Brotli itself? It just optimized text files. So there was this research done which scrapes thousands of most used URLs on the internet, and they found out that in in average, you can get 40% smaller JavaScript, 21% smaller HTML, and 17% smaller CSS. And this is not smaller than, you know, not using compression. This is smaller than gzip. So it's comparing this 20% reduction to gzip. It's just much better at its job. It has wide support, and it can be even faster with small output. So it can be faster than gzip itself if you need to do it, for example, on runtime. Sometimes you can even optimize JSONs, so like when your server returns a response as a JSON, you can do that at runtime with Brotli, and it will be faster than gzip if configured correctly. So, other than compression, when you are building the application, there is a magic happening behind this command. In the new Angular, you don't even have to provide the prod, just because there was a problem in community where people didn't really understand what the prod is for. So they actually made it optional, and production flag is now default. So first thing that is happening when you build with production is tree shaking. What is tree shaking? It looks something like this, but in real life, this is a very good comparison to what is actually happening, because you can imagine it behind the curtain that is really shaking the tree, and when it stops, it waits for a bit and then again shakes it, and all the things will come down because they are not used, they are not attached to anything. So it will just tree shake everything that doesn't have to be there for application to run. It's a term used for dead code elimination. So dead code means that there is no way how this code could be running. And if you imagine in Angular something like you are using this environment.production, which can be true or false, and you are flagging stuff with it, that's a perfect example, because that is a constant that you provide on build time. And this constant provided on build time can be used by the compiler to tree shake things. So most of you, if you use this, will actually see in your application that if you hide something behind this constant, often this code will disappear because it's unreachable. It relies on a ES 2015 module syntax, which basically means import export, like we know it in modern JavaScript or TypeScript. And with tree shakeable libraries, the side effects are forbidden. And to explain what is a side effect in this context, you can imagine it we've seen the talk, it started today with what is this? So around this, there is this term called prototype, and everything that is tied to prototype usually means something bad. And like in this context, so don't use any prototype. I want to say editing, but you know, extending and manipulating with things, modules, because it's basically a side effect. The compiler will never know what you are doing, so it has to keep all the code intact, and that means that it will not be optimized. There is this ahead of time AOT in Angular, which is a very nice thing. It happened around I think Angular 9. It was it came from optional to non-optional. So it significantly reduced the Angular bundles. It basically means that if you build with AOT, you are processing all of the templates, all of the imports beforehand, and you are not shipping the code that would have to do that in your application to the production. So users will actually never see that code. It had a significant impact on how bundles were big. And it can also do that it actually provides you with a tooling for HTML. So all this fancy stuff that is happening, like for example, transpiling the Angular templates to something that is actually used in runtime in Ivy, for example. So that is all done in this compilation step, and it enables us to use static analysis to reduce the size, because if we statically analyze the HTMLs and know what components, what pipes and other things, what is used in the HTML, because we understand it thanks to this compilation step, then we can work with the templates. Otherwise, we couldn't, because the template would be just text for us. It would not be a real JavaScript code. Thanks to this, it is. And it also enables type checking. This is the reason we have a type checking in the template, because we are compiling beforehand, so it knows what you are doing when you use ngIf and put something into a variable, and it can just know what the type of that variable will be, thanks to the ahead of time compilation. Code splitting is another tool, or it's not a tool, it's a technique that is also happening behind the curtain, and it is basically achieving this. Everyone probably seen it already multiple times, maybe even every day. You build something or serve your application, and you will see all of these bundles, and they can be named like this, like 1, I don't know, 10, 7. It can be actually named marked dot something, highlight languages. It can be main. You can easily identify this with, thanks to the name column. But what it really is, again, is just your application split into multiple files, and all of these files are loaded lazily, or they can be even loaded together if they are shared between modules. But this is a really complicated topic, so let's not go into that. We can just say with code splitting that the behavior of application should stay the same. It shouldn't change at all. Like this has to be 100% true for the compiler. Whenever you extract some of the stuff to another file, the application should still behave the same. The business logic shouldn't change. All of the chunks, or most of them, can be loaded on demand, and this was again perfectly described in other talks, so I'm not going into deep, but these are lazy. They are even labeled lazy chunks, so they will be lazy loaded. And the common is basically shared code. So if you see common somewhere and it's huge, you probably know that you have the problem with common module or with shared code. Maybe you have a lot of external dependencies, like for node modules, or maybe you have a third-party library that is horribly huge, and I can even show you the example later. So there was this amazing talk today by Deepa on lazy loading. Thanks to it, I could delete few slides. I'm thankful. So it's this. To be honest, like if you do this, you are halfway there. You achieved a lot of stuff. Please do it. There is no reason not to. With preloading, again, a lot was mentioned, but what I can say is that it affects size and performance, because size is one thing, and we all know if it will be faster because it will load faster, that is very nice. But if you correctly preload, you also affect the runtime performance thanks to browser it will not need to process the scripts that it doesn't need to process. So if you implement correct strategies, and some of them are naive, custom, link-based, or AI-based, you can achieve great things. Naive is basically what is currently built in Angular. It can be preload all or preload nothing, so that's why naive. You can write custom ones, it's pretty easy. We've also seen today how, and you can use some of these perfect libraries. QuickLink will create the preloading strategies based on links. It will crawl all of the links on build time. that you have in the templates, and it will basically put everything that you can navigate to as something that should be preloaded. It's pretty nice. For most of the application, it's enough. And and the AI based, it's Guess.js. I think it's from Minko, and it basically uses machine learning to know what your users are doing and what should be preloaded. So if you need this, it's worth checking out. I know from my experience that quick link or custom is usually enough, but it is very nice that we can use AI even in routing. This is a very nice comparison of what are the steps you are taking in Angular application. And it is just an example, but the numbers will probably, or the columns would probably look very similar if you would skip some of the steps. So the first one, the biggest one, is the bundle only. So that means that you basically build or serve without the production flag. It will be this huge. If you bundle and minify, it will, be a third of the size. If you also minify and gzip, again, third of the size. 3shake, and then so on until we get to everything pre-compiled, 3shake, bundled, minified broadly, and we can see that it is what, maybe 20 times smaller, and this can have a significant impact. Like I'm sure that you in your life stumbled upon an application which you knew in that moment that you were opening up in a browser, you knew that this is not built for production. Like someone forgot, or they are not using compression at all, or these things you can tell as a user. So this is why you should do it. And now we can talk about the toolings, because tooling is important. Without the tooling, you will not be able to achieve a lot. So if you use VS Code or WebStorm, there is tooling called Import Coast. Import Coast is very nice. It will offer you this overview. You will basically, it's a screenshot from my WebStorm. So it will tell you fast db equal, it's kilobyte, not even a kilobyte when gzipped. Nobody cares, what's a kilobyte. RxJS, okay, that's significant, but I need it, and it's probably already bundled with Angular, so keep it. But then you go to, for example, Firebase, and you notice, why is the Firebase so big? Well, maybe because we did a bad import, or maybe because we didn't import from the feature modules of Firebase lib, because they offer that now. They didn't in past, but now you can actually import only features you need. So you probably should do it. You don't do these. It's like global imports. And the Quill, last thing, it's a editor, like for vCVig editor, again, huge. You can immediately tell that this is probably something that you shouldn't do in this component. Maybe you should do it somehow other way, lazy load it. And then most of your users will not pay the price of the editor when they don't need it. If you need to analyze the bundles to see what's going on inside, you can run these two commands. It's all included in the first one is included in the Angular CLI. The second one just mpx, and it will run the Webpack bundle analyzer. This tool is actually not recommended by Angular team, but there is a thing that it will offer you a nice overview of what's going on. You cannot trust it 100%. Like I wouldn't, put my hand into a fire for it, but it is pretty good, and I can show you why. Because it will result in these very nice charts. And these charts are actually zoomable. You can filter them. You can have a look what's inside of each of these small squares. And I have a neat example on how you can actually identify that something's not right in one of these charts. Because when this is your application, you tend to be able to read it. You understand what's going on. You can identify the stuff that you see. You can read that map component. You can see it there, pinkish color. sorry, I'm colorblind. So the map component, probably something wrong with it, because why is my web component like 1/5 of the application? I should check it out. And explore the bundles. So if you go inside of them, you can see something like this. Again, a screenshot from actual application. They were using an import for Highlight.js. Highlight.js is a library that highlights the code to make it nice for a blog post, or for your page if you have a code there. And if you have a look, it's not really readable, but size says it's 1.2 megabyte. So this library will cost you 1.2 megabyte of bundle import, and it doesn't have to be this big, because who knows these languages? These are actually languages that like highlighters for these languages. What is 1C? Does anybody know what is 1C? Or Mathematica? That you probably know, no? Well, never mind, this proves my point. If you don't even know these languages, why are you importing the highlighters for them? You can do something like this. You just make it smaller, because you can handpick the stuff that you actually need, and then you can realize that now something that was 1.2 megabytes is something around 100 kilobytes, which is gzipped 16. I cannot read it, but I think it says 16. And that's the point of it, that you only have the core, which is pretty small compared, because all of the stuff that you can see now on what is it, left, you don't even see these small squares down there. They are so small you cannot even identify them. And you only need, for example, you only need TypeScript, SCSS, Bash, and Markdown.js for highlighting, because that's your common web developer tech stack. And I am not even importing JavaScript or CSS. Why? Because TypeScript is superset of JavaScript, so I can use the TypeScript highlighter to highlight JavaScript. Same with SCSS. Valid CSS is valid SCSS. So it's not a micro optimization at this point, because you can achieve great reduction. And we can see that we did a reduction of 95% just by doing this manually. And it was just few of the imports. I don't have the screenshot of the code, but you can imagine it as like, in that square brackets, you just mentioned what highlighters you actually want. That's it. Bundlephobia, great site. You will just write what library you want to know something about, and it will show you something like this. And this is an old screenshot from RxJS 5.5. And there is a reason why I picked it, because you can see the spike in version before, it's before 5, it's 4.9. And do you know what was this change? Does anybody remember what happened between 4 and 5? It has something to do with prototype. And to be exact, it actually, you probably cannot read it, but it says that it switched the imports. It switched the imports to ES 2015, to the new import export syntax, and the library got tree shakeable at this point. So we can see first the reduction, and second, now all of the stuff that was in the RxJS was first smaller and hand pickable by all of the you can be very specific about what you need, thanks to the change in tree shakeable library they made. And you can explore these things when you are choosing the dependencies. You can see what you will be committing to using that in your application. So you can be careful about it. You can set budgets in your application. You can watch its size, and you can use AngularJSON to write whatever you think it's reasonable there. So you can write something like this. You just set initial budget for warning 200, error 500, and then vendor bundle should be baseline 50, and more if it will be 50 more than baseline, that it will give you a warning. If it will be 100 more than a baseline, it will give you an error. And it will result into something like this when you I intentionally did something wrong there so you could see it, and these are the warnings that you see in a console. You don't have to be afraid when you see some of them, because they are actually saving you from a trouble in production. They are saying you exactly that you should have a look on that initial bundle of yours, because suddenly it got much bigger. And for sure you have to do something with vendor, because it is currently twice as big as it used to be, and it's not good. So budgets are a very good thing. Not a lot of people use it. You have to use it carefully, because otherwise you will be bumping budgets every day. It's not a very good technique to bump them every time you see a warning or error. But there are some compromises you can take to achieve a good symbiosis. With Angular, again, this is not a news in any huge announcement, but there are conditional polyfills. They are there for quite some time, and not a lot of people know about it. But if you configure the browser list properly for the browsers you actually need to support, then all of the polyfills, and I'm talking JavaScript and CSS, will depend conditionally, and you can actually save a lot of kilobytes for modern browsers. So it will actually look something like this, and you can see that there is the polyfills thing which is separated, and like this is what you normally do. If you ship for, sorry, I can't go that far. If you ship for modern browsers with differential loading, the polyfills or the bundles in general will use this syntax, which actually takes advantage of module and no module syntax in modern HTML, where some browsers actually understand the type module and they will load it, and some browsers doesn't understand the old one, so they will not load it. They will just skip the ES5 syntax. You can then ship modern code to modern browser, old code or polyfilled and patched and everything, much bigger code to old ones. So you can have advantages on both ends, because your application will actually work the same for all of the users, but you can ship the modern stuff every time. ES5 is not modern anymore, but I'm sure in a year or something there will be another solution for this, and it will still be very convenient. When we are talking about optimizations, we can't forget about optimizing the static assets. And there are things like SVGs. You can, or you should, use the SVG OMG. You can find it on GitHub. It's pretty nice. You can reduce a lot of SVG content to bare minimum. You can get, SVG that is half a megabyte can suddenly be a kilobyte or something. You can reduce the size of images in general. You can use the image webpack loader, which will optimize on a bundle. Not compile, but when you run the build process. And you can also use the sites like TinyPNG, where you just put your image in, and it will output something which is much smaller. And they also have a API which has like 500 free requests, and after that it's very cheap, so I recommend that. And if you use modern formats with your images, you can get even better results. So there is this something called WebP. It's a format of images, and if you use them instead of PNGs, you get 26%. If you use that instead of JPEGs, you get 25 to 34. So about a third of an image size can be saved just by using a better format, which it can be pretty significant if you consider that your images can be in megabytes, if they are good quality. WebP is pretty much supported, and even if it's not, you can still use construction like this, which is basically using a picture tag and then having a fallback for a JPEG, but using the WebP as a default one for modern browsers. And if we have an example like this is like a really nice photo of rice gardens, which is pretty big. Sorry, it's pretty big. It's 9 megabytes. If we scale it down to a preview version, so something that would show up when I click on a detail so I can see it big in my application, it will be like 3.5. If I actually use, you know, a lot of these huge, nice photos in my application, I want to optimize them. For example, for thumbnails, because in my application, most of the users, mobile users, everyone will basically first see a thumbnail and the big picture almost, like, in most cases, they never open it. So how small the thumbnail can be. If we do everything correctly, set the size and optimize it with the, for example, tiny PNG or anything else, we can get around 40 kilobytes on the same image. And I don't even know, yeah, now you have the numbers. It's about 1% size of the previous big one. And like this is already a huge saving. And if you realize that you have in your application thousands of these images everywhere, why not start doing it? And the easiest thing you can start doing is using an image delivery APIs. There are a lot of content delivering services, CDNs or whatever else, like web applications that allow you to, you know, access an image via an URL, and also saying what should be the dimensions of the image, like to dynamically resize. And they will actually cache these results. So these results, first time it takes seconds, but then every other time it's requested, it will be very fast. And with this syntax, I'm not sure what site is this one, but usually this API is very similar. So you can easily do it like this. You just create a pipe for for a string like this, and it will do everything for you. And one last thing, how to check if you are doing a good job. Lighthouse, for sure. But you don't really want to be doing that every time, every day after each release manually. So what could you do is to run Lighthouse automatically on CI, because it will tell you a lot of stuff. And if you are really in the market for optimizations, and not only size, but also performance, and actually checking and measuring what you do, then definitely check these things out. And I can highlight the last one, which is a tool Michael made, and it will actually integrate user flows into your Lighthouse checking, and it will tell you everything you need to know about the specific path the user is taking and what is happening. It will tell you the performance, it will tell you that there are huge images that you have to switch, it will tell you that you are using a wrong format, that you are still on PNG and not using a WebP. Everything will be there in the report, and it will be automatic. It's great. I definitely recommend it. And with that, I say thank you. You've been a great audience.